Hi, everybody. My name is Josh Wills. I work at a company called Datology AI. I am also a sort of reasonably well-known DuckDB enthusiast. That's sort of how I introduce myself. So Datology is a company that does data curation for foundation models. So every day I process about 30-ish terabytes or so of data using Spark and Ray and Flight as my sort of orchestration engine. So I am still doing big data stuff, even though people don't really do big data stuff anymore, apparently, I guess. I don't know why that is. It's one of those things. I still do big data stuff. I am also kind of sort of on hard in the other direction. I created the very best DBT adapter you can use, which is DBT DuckDB, which was really like an attempt to like really sort of imagine what it would be like if DBT was really, really awesome and wanted like awesome people to use it, basically. And that's sort of been the ethos of the project the whole time, is doing all the stuff that the wonderful people at DBT Labs do not want you to be able to do. I am also an angel investor, recreationally, like it's an amateur thing. I have no interest in going pro, in companies like DLT and DBT and Tabular, which recently joined Databricks, and MotherDuck, and about like 40 or so others. It was kind of one of those pandemic hobbies that kind of got a little out of hand, right? Some people baked bread, and this is what I did. So yeah, that's a bit about me. I want to talk a little bit about data quality. What do we talk about when we talk about data quality? Most data engineers, sort of data analysts, scientists, analytics engineers, what have you, they talk about data quality. For them is kind of a euphemism for the fact that upstream engineering teams and systems don't really care about data, basically. So data quality problems are things like the schema was changed and no one told us, so everything broke. Or we have had to reproduce some upstream business logic downstream in a SQL data pipeline, and the upstream business logic was changed, and again, no one told us, and so we didn't find out about it until later, and so things broke. So I just want to kind of, again, I'm not really here to sell anything. So like, I'm not here to sell a data quality tool, so I can just say outright, this is what people talk about when they talk about data quality, okay? Kind of along the lines of like the rise of people talking about data quality, there has been this broader movement in the sort of like DevOps software space called shift left. Shift left. Now, if you don't know the term shift left, it kind of emerged from the study that was done many years ago, which showed kind of roughly that the vast majority of software defects were introduced during the kind of the coding phase of creating a piece of software. And the cost of detecting and like the sort of the cost of fixing the defects go up by several orders of magnitude as we move from the coding phase to the unit testing phase to functional testing to systems testing to sort of release. And so the mantra of shift left was basically, let's move sort of things we are doing later on in this life cycle further to the left. So things that we do unit testing, let's make them coding things. Things we do in integration testing, let's make them unit testing things. That was broadly the idea. I have to be honest, like as a software engineer, the term shift left kind of like, it gives me like the howling phantods, basically, because it has been a term that has been like largely co-opted by vendors to mean I want to move work to the software engineering team, but not move any resources. Basically, like I want the engineers to do like even more stuff. I want to shift security left. I want to shift testing left. I want to shift ops left. I want to like pile on work to software engineers. And so the sort of the ethos of my talk is like, I don't want you to shift stuff left. I don't want you to shift data quality left. I want you to shift yourself left. I want you, data engineers, to come work with backend software engineers in order to improve the quality of your data pipelines and sort of software systems as a whole. That's really what I want. And the challenge when I say this to data engineers is they sort of look at me in kind of this puzzled, confused face, and they're like, but Josh, I can't do that because I have the data warehouse, and the data warehouse is big. It's built for scale. It can't run inside of like an integration test. Do you know how much money it would cost us if on every pull request we had to like load data from Fivetran into Snowflake and then run tests on it? Like, that's insane, Josh. Are you crazy? Right? And the problem, and the thing that I'm like, kind of the reason I'm talking about this is that data engineers sort of like all engineers are kind of in thrall to some monolithic system of some sort that sort of, it defines their identity. And for data engineers, that's the data warehouse. For front-end engineers, it's the browser. For mobile engineers, it's the mobile SDK, right? For the backend engineers, it's the OLTP system. That's sort of like what defines them. And what I'm asking them to do is sort of break free of that monolithic style of thinking and focus on solving problems wherever they occur, solving data pipeline problems wherever they occur. If they occur on the front end, if they occur on the back end, if they occur in the data warehouse, great. But let's not like restrict ourselves and not define ourselves in terms of this monolith. This isn't really good for anybody. Because of sort of the need and the sort of special sort of bigness of the data warehouse, we've had to come up with kind of workarounds and solutions and things like that for shifting things left while still doing data engineering things. And over the last couple of years, until kind of AI took over everything, the watchword was data contracts. Data contracts on LinkedIn. If you were in LinkedIn in like sort of 2020, 2021, basically impossible to do anything without hearing about data contracts, right? So what are data contracts? Data contracts are just API specs. It's like an open API specification. It's like, these are the fields. This is their name. This is their type, right? It's like a sort of static definition like this between an upstream data producer and a downstream data consumer. And data contracts are very, very good. Data contracts are great, but they aren't sufficient, right? Even when we have API specifications, open API specifications between upstream and downstream systems, we still integration test stuff. We still make sure the business logic works. This sort of the schema definition stuff is not, in my opinion, sufficient to really test and be sure that things are actually working the way we want them to. So what should we do? I have been looking for a different way to have this relationship work. I've been looking for it for a really, really long time. Once upon a time, I worked at Google. And when I worked at Google, we did integration test our downstream data pipelines with our upstream systems because we had to. That was where all the money came from. And so it was really, really important that everything worked. And so there have been a lot of people sort of talking about this idea and talking around this idea, and I included links to all their stuff here. And really for me, like what makes me so excited about DuckDB is that DuckDB is for me sort of started this journey to imagine what would it be like if I could run my entire data pipeline on every pull request, every single one, every single upstream system, every single change. I could run everything end to end and make sure that my data pipeline still worked the way that I thought it should. And so I want to talk about the steps, like sort of the processes, the things you have to do as a data engineer to sort of embrace this journey. And it's not really like a sequential kind of thing. I'm labeling them with numbers, but that you can do them kind of in any order. The first thing to do is you have to containerize your data pipeline. You have to take all of your sort of tools, all of your dependencies, be it dbt, SQL Mesh, DLT, evidence that that's your BI stack. All you need to basically take all that stuff, wrap it up, put it inside of a Docker container so that it can run alongside the rest of your production systems. That's like step one. Step two, you have to understand how your team does CICD. How does CICD happen to your company? There's a million different CICD tools. They're all terrible. Everyone hates them, like broadly speaking. It's a universal phenomenon. If at your company they hate the CICD, it's okay. Everyone hates their CICD. It's kind of awkward. It's probably like some CICD vendor investors here. That's okay, it doesn't matter. It's fine. Anyway, understand how your team does CICD. Understand how it works at your company and combine your containerized data pipeline with your team's CI/CD system to integrate your data pipeline system, your data pipeline runs into your upstream integration test pipeline. And then steps 3 to infinity, ask questions. Ask questions. Join the DBT Slack, join the DLT Slack, join the DuckDB Discord. Claude and OpenAI and Gemini are instantaneous access to the world's worst DevOps engineer. They are there to answer any of your dumbest possible question can be answered immediately by the world's worst X for any value of X. It's like an amazing feature. You can ask as many dumb questions as you like. Claude is my little intern. I love it to pieces. We work together on coding projects all the time, including the one I'm gonna talk to. It has never been easier to learn about the details of adjacent engineering disciplines to the work you do. It's like a magical, what a time to be alive, okay? When you do this work, when you containerize your data pipelines, and when you understand how your upstream CI/CD systems work, you will discover, as I have, that ingestion is the key to making this work. How do you move data from those upstream staging databases into DuckDB, into your data pipeline? And this is why I am so excited about DLT and why I'm an investor in DLT, because I've been looking for someone to do this for me for a really long time, which is make data ingestion just a Python library that I can configure as I see fit, that I can squeeze in wherever I want it to go, and that it will work at the largest and the smallest scales that I can throw at it. All right. A lot of times, all you really need is just a way to get started. And so that's what I've created. I sort of woke up at 3 a.m. I couldn't sleep. Probably not talk about why. And so I started working on this. This is my GitHub repo, jwills shift yourself left. I have a simple like recipes web application there. I have a dbt DuckDB and DLT data pipeline project that depends on it. And I have a whole integration testing hook using Docker Compose to tie the two together to run integration tests from the upstream system to the downstream system. And it's designed to be as simple as possible to get you something that you can understand. It's not got a bunch of unnecessary complexity in it. It's just there to like sort of let you see how this all fits together and give you ideas for when you're talking to your own team. And that is my challenge to you. And that is my fun sort of DALL-E generated image of me as Smokey the Bear. Data, only you can save data quality problems. And that's it. Thank you very much.